Good morning and welcome to the start of the 11 o'clock sessions. Matthew McGlam, I'll be moderating today's session. I have Jay and Rob with me today from Wake County Public School System, and I'll hand it over to them in just a moment. On the right side of your screen, right beside where the video is playing, there's a green chat icon. Go ahead and click that and join the chat. Be sure to send in your questions throughout the presentation. I'll be coming back online at the end of the presentation to read out any questions that may come through to Jay and Rob. So please go ahead and put those in there, and I appreciate you doing that. This presentation and all the other presentations will be available at the conclusion of the conference on the NCGIS Conference YouTube channel. Once they're all up there and ready for your viewing, we'll make sure we send out an announcement to everyone so you can go and check out any presentations you may have missed or rewatch any presentations that you want to remember what was said and discussed. So please be sure to check that out when the time comes. We will have a break at the end of this presentation for 30 minutes from 11:30 to 12 o'clock. So if we do go a little bit long in this one, I'll let you know. So don't feel like you have to rush off. We do have a closing session at 1 o'clock after the next round of sessions. That closing session will only last about 15 minutes, so please make sure you tune into that. The poster session winners will be announced during that time as well. So without any further delay, I'm going to turn this over to Jay and Rob for their presentation on Gifted and Talented, Identifying Student Potential Using Spatial Statistics. So Jay and Rob, the floor is all yours. Thank you so much for your time today and look forward to your presentation.
Thanks, Matt. My name is Jay Carter, and I'm here with my colleague Rob Siwek. We're in Wake County Public School System. I'm in the Department of Data Research and Accountability, and Rob's over in Office of Student Assignment. So wanted to give everyone a little bit of a taste of what we had done in Wake County in terms of gifted and talented identification. So we can jump into the background. So won't spend too long, but generally the purpose of gifted and talented programs, AIG in some places, gifted and talented in other places, but generally are challenging students with high aptitude and performance. It's actually statutory in North Carolina that we run gifted and talented programs. It's Article 9B, if you want to look it up in the general statutes in the education law. So all of the districts must have gifted education, AIG programs in North Carolina. And generally, this is nationally, gifted programs generally use some sort of tests. Could be IQ test, could be a Woodcock-Johnson, could be something like the COGAT in Iowa, test-based skills like we have in Wake County. But generally, what you end up doing is giving some number of kids a test and take the top X%, usually it's like the top 5-ish% of students. And the tests are nationally normed. But recently, there have been best practices in gifted education. One of them is to test more students. Wake County is out in front of that for at least 10 years that I can think of now. We test all our third graders, so that's a good thing. So you don't have a teacher in between a kid and possibly qualifying for, or a teacher recommendation or a parent recommendation in between a kid and possibly qualifying for gifted education programs. But now these best practices are to compare students more locally. So we call this local norming. And so what local norms are is they compare students to their peers instead of to some big national scale. So if you take something like the COGAT, Cognitive Abilities Test, they norm this nationally. So they give it to a group of kids from all over the country. And the scale scoring becomes based on what these kids do. That may not be particularly useful in any given school district. Students don't live or learn nationally. They don't develop nationally. Students develop within their specific context, and that specific context is generally at the district or school level. And this is another way to have gifted programs that more accurately reflect your district in terms of both performance, but also in terms of demographics. There are some challenges to this approach that we'll go through later, and basically the entire presentation is about how we solve some of these. If you want an example, the Texas 10% rule is basically everyone that's in the top 10% of their high school class, or at least how it was written in 1995 or 1996 after the Hopwood Supreme Court case. Everybody in the top 10% of their high school class gets into UT. Now, UT San Diego, UT San Antonio, UT Austin, you can go to one of those schools. And so what they've kind of done is, since schools are segregated in Texas and elsewhere, if we take the top 10% of schools into the UT system, we will get a more representative balance of students than if we had just let admissions processes run as they were in other places. This kind of takes advantage of school segregation, but that's not really how we have done things in Wake County. It's has a history of using student assignment to take care of school segregation more than other places. So let me go through an example, a conceptual example, and then we'll get back into local norms. So if you look at local norms, in school one, if we took everyone above the 95th percentile, we'd get everyone above the black line. The black line is 95th percentile nationally, so you get about 20 students here. But if you took the 95th percentile locally, that's going to be just the kids that score 99th percentile nationally. In school two, it's still a relatively high performing school, but just not as extremely high performing as school one. So the 95th percentile in that school is 4 kids, whereas in the 95th percentile in school one is 7 kids. The problem is when you run into school like school 3, which has some kids that these is not a low performing school in any way, shape, form, or fashion, just not as absurdly high performing as some of these other schools. We're talking top 5% nationally. And so there, if we only went with the top 5% nationally, in school 3, you'd have 1 student. And that doesn't make a whole lot of sense because there's probably some other students in that school that could use a challenge. And we're going to try to identify those students, or at least give them an opportunity to get into the AIG program. And so you end up going down to the 88th percentile in that school, but it's not like we're letting in a bunch of kids that can't do work. It's just we're looking for students that could use a challenge in their local context. Thanks, Rob. And so I want to start with a little bit of like, where do students in Wake County live? And so just kind of try to hold, if you know anything about the geography of Wake County, just try to hold that heat map in your head for a little bit. I just want to show it here. I'll show it again. But if you'll notice, like there are places that students live in, places that students don't. This is not that surprising. Wake County is a big place. You know, in the northwest corner, there's an airport. Like people just can't live there. But there are places that lots of students live and places that hardly any students. So if we go to the next slide, if we're going to do local norming, we have to have a comparison group. This is the entire point. We have to have a more local comparison group than nationally normed tests. So how do you find a comparison group? Well, we could use some geography-based stuff. So zip codes, but zip codes are for routing mail. They're not geography. This is what you always run into. Someone will ask you, well, what if we do it by zip code? I'm like, zip code's not a geography, I promise. You just have to look at a map of them to figure that out. Or what about catchment zones or base attendance? We call them base attendance areas. These are the zones around the residential areas that go to certain schools. And as you can see on the right-hand side, I've given a small cutout of the base attendance area map. They're pretty strange geographies. And these are student assignment geographies. They're not neighborhoods necessarily. They're not anything else. Like they're purpose-built for assigning students to schools. And in Wake County's case, historically have been used to keep schools from being but so segregated. You could use census geographies, but again, we'll get to why that's problematic in the next couple of slides because students live in certain places and don't in others. So if you can go to, so here are, these are census block groups. It's the same map on both sides, just color for percent white on the right and percent black on the left. So you can see that this school district is somewhat segregated, but not extraordinarily segregated. And then there are some places that are light on both, and those are just places where not very many kids live. On the next, and so you can see the similar thing with percent Hispanic and percent Asian. We can keep moving. And then the other thing you'll notice is that the economics of Wake County, a large county, relatively affluent overall, very wildly, geographically as well as in terms of just overall economic health. And you can see some places are lower or higher economic health. And this is an index that the county uses that has indicators of vulnerabilities affecting households and communities, such as like homelessness or percent in poverty. Next. And so the other way you can come up with comparison groups is to just count the kids, right? So you can take a kid and maybe say everyone within 2 miles of him. But the problem is, again, the density, right? So some students you may have 250 students within a mile of you. And other students, there may be 6 or 7. And so it's hard to find fairer comparison groups there. And so what we've decided on is this clustering approach. So we're going to use the fact that anything that you can attach to an address or an XY coordinate is spatial data, run through some spatial algorithms, and come up with more of a clustering approach to find this comparison group. Yeah, we can skip that. Sorry, I'm going to take it out. Thanks, Rob.
Okay, so thanks, Jay. With that clustering of those student points, we run the local Moran's spatial autocorrelation statistic for each point in the data set of those 3rd grade points that we saw. This tool is called cluster and outlier analysis in ArcGIS. When we take a look at some of the specific outliers from the results of that analysis and rank local test scores within a specified distance of that outlier, then we can establish local norms for those groups of students. So here we have, again, the distribution of 3rd graders who all take the same tests, geocoded within the district and county. We have a point for each of our enrolled students in the county, and that gives us some really good data, a large scale. And we can attribute a student point at any grade level with scores for any test. For our analysis, we looked at about close to 12,000 3rd grade students who all take a number of tests that year. 3rd grade is also the year our advanced learning services AIG staff begin to assess students for that program. So when we run that cluster outlier analysis on this data set, what are we looking for? Will the scores across the county exhibit some randomness, or will there be distinct clusters of test scores? And can these clusters be considered a new kind of geography for local norms, like a new peer group geography? So this is a list of the output types after we run the statistic on the data set. We have clusters of high values with high test scores, clusters of low values, and then we have the outliers where there's a high value surrounded by a low value cluster, which is what we focus on for this analysis. There's also the outliers of a low value surrounded by a high value. And then there's a number of scores that are statistically insignificant or just random. Here we have the results of the analysis showing clusters of high scores in red and LL low in blue. And the gray are those of no significance. The red and blue points would have positive I values. I left out the outliers in this image so you can see the location of those high and low scoring areas. We'll look ahead at the clusters and outliers in more detail here. Here are those areas strictly of the high test score clusters. And here are the same areas with the outliers in yellow. So that would be a low score, test score in the high area. And these are values that are exhibit spatial randomness. So there's no real clustering of the scores for these students. The points are clustered, the test scores are not. Blue is the cluster of low values, and this is what we focused on in this analysis. And here are those low test score clusters with the outliers in blue. So it would be an HL classification in this in the tool set in the results. So we are going to focus on those high test scores in the cluster of low scores. This is these are the counts of the different clustered outlier types for this specific data set. And again, we're looking at the high-low, and there are 1,325 students we identified with as outliers in these low scoring areas. So what we want to do is take an extra look at these students to develop those local norms. Here's a density of those high-low outliers throughout the county. And here we have those pink dots are those students we identified, those 1,325 students. And what we have in the raster in the heat map are the current AIG students in Wake County. So, you know, there's kind of a east-west divide there, with, you know, high concentration in the west of AIG students. And in those areas that there's some overlap, but a lot of these areas with the low density has an extremely high number of the outliers. So after we run the local Moran's eye statistic, we generate a near table for each of those high-low students. So we'll take a student who's high-low, and within a mile of that student, we'll examine all the rest of the test scores. And this is the solution to finding students near neighbors to make a peer group for comparison. So within that mile of the low scores of that student, we'll look at all the scores to re-rank and score. And this is the peer group. So using some Python geoprocessing tools and scripts, we group those students, rank the scores, and then establish local percentiles for the AIG teams to review. So we'll have those new kind of geographies for students' peer groups. And this process we can run using multiple test scores for the same set of students or different grades, different tests, etc. And that's all we have. Thank you.
Well, great. Thanks, Jay and Rob. I appreciate that. That's a very interesting study that you've done, and it's always you know, great to see how you can take certain data and information and tie that all together and see it spatially, and you know, start to reach some conclusions and at least some receive some results from that analysis. So that's great. I appreciate you all sharing that. I do have the chat open. If anyone has any questions or any comments or items for Jay and Rob, please feel free to throw those in the chat, and I'll read them out. And I'll make sure we'll stand by for a couple minutes to give you an opportunity to do that. Patrick Williams did put in a question, Jay and Rob. He said, what functions or parameters, etc., did the Python scripts utilize?
we used the nearest, I believe it was a near tool, nearest distance tool. We calculated the I'm trying to think now. Yeah, we looked at all the students within a mile and created a near table. So it ran through all those high-low students, ranked, scored, created percentile. Most of the work is done in that cluster and outlier tool. It's just there are millions of records in this to get all these kids in their peer groups. So I guess that's the main thing we use Python for to help us with that.
Right. Yeah, did it take a while to run that with so many records? Was it something you were able to do on, was it on a workstation, like a standard workstation, or did you do it on a server environment?
Standard workstation.
Would have been nice.
It's it's not too, it's not too time intensive. It's just how many tests you want to run, how many different students. But an initial run with this one data set isn't too bad.
Right. And is that something? Did you have to geocode all the records, or was it? Was that one of the first steps, or did you already have XYs, or I guess you have XYs now?
We have we keep maintaining a student geocode for lots of reasons, including this. And then there's a lot of testing data that is separate that had to be cleaned up and put together, and that took some time.
Sure.
Yeah, the joint tables aren't too bad because they did all the hard work for student assignment stuff.
Right. Stacy asks, are either of you aware of other counties in North Carolina that are doing this or something similar?
I'm not. If you are, I would love to touch base with folks. I know a few counties that test all their students. I don't know if people are actually using spatial data.
Right. It'd be interesting to see how if there were neighboring counties that were doing something similar, because obviously you have a hard line for your county, but there's other students on the other side of that border, and to see how things continue across. So yeah, that would be interesting. Colleen said, will you use the results to target identification of AIG students in the lower scoring areas?
Yeah, so that's the idea. If you go back to the overall concept of local norms, it's just finding students not based on what somebody in Washington State did. And so where our part ends and the ALS folks begin is okay, here's a group, here's where kid X ranks within their near neighbors, their near peer group. And then it's finding out and then they have to figure out what reasonable cutoffs there are, what fair cutoffs there are within the near peer group. But yeah, that's the point, is to try and find kids who could use some challenge that are perfectly great students, but just not 95th. I mean, imagine how 95th percentile is way to the right tail. And there are some kids that can do great stuff in AIG programs, and we're trying to find those.
Right. Good. Brett asked, what's been the biggest surprise in your findings?
They were more random. So it's surprising. There's surprising findings and then surprising trying to communicate them. And so there were more spatially random clusters than I had anticipated. And if you stare at the gray dots in that map, you're like, that looks a lot like a cluster. Are you sure? And the answer is, if you use a p-value of 0.05, then the Moran's eye has to be really sure it's a cluster. So some of that stuff, I thought places that would have been clusters were not. Other than that, I don't know if you're around Wake County much, the map won't surprise you much. And so, yeah, I think it was mostly like how easy it was to detect actual clusters, and then how hard it was for the statistics to say, you know what, that's really a cluster and not something that, I guess it's not completely random. It's just I'm not sure it's not random. Was the
Right.
I don't know if Rob had any other surprises, but
No, some of the math, when you visualize it, it's an eye opener. But again, when you're used to the geography and you know, the demographics and distribution of Wake County, it's not surprising.
Well, Diane Enright commented, great job in the chat. And I think that's all the questions that we have at the moment. So Jay and Rob, again, I appreciate your time and the effort in the presentation. It was great to see that and to see the work that's going on there in Wake County Public School System. So thank you again. To all the attendees, thanks for tuning in. There is a break starting in just a few minutes, so enjoy that break, and we'll have a couple more rounds of sessions coming up at 12 o'clock, wrapping up the conference with the closing session at 1 o'clock. So again, thanks everybody for tuning in, for attending the conference, and I hope everybody has a great rest of your Friday and a great weekend.